Welcome to an extraordinary journey into space, where we will collectively unveil the deepest mysteries of the galaxy we call home, the Milky Way. From its giant spiral arms to its dark heart, where a supermassive black hole resides, the Milky Way is a treasure trove of the unknown, inviting us to explore. Get ready to pull back the cosmic curtain and discover the wonders our galaxy holds. This is not just a story about a galaxy, but a story about our place in the vast universe and humanity's greatest questions. Welcome to SpaceTime's cosmic journey, where we delve into the universe's deepest mysteries. In this video, we will explore the Milky Way and its uncharted secrets. Don't forget to subscribe to the channel so you don't miss out on other exciting cosmic exploration videos. If you find the video interesting and useful, please like and share to support us. The Milky Way, also known simply as the galaxy, is the home galaxy of our solar system and Earth. It is a giant barred spiral galaxy, estimated to contain between 100 and 400 billion stars and measuring approximately 100,000 to 180,000 light-years in diameter. With a mass up to 1.5 trillion times that of the Sun, including dark matter, the Milky Way is one of the largest and most complex structures in our local universe. It is not static. The entire galaxy is rotating, and our solar system completes one orbit around the galactic center approximately every 220 to 250 million years.
This means that each time we complete a galactic year, life on Earth has undergone tremendous transformations. This rotation is not uniform, with stars and matter in the center rotating faster than those in the outer regions, a phenomenon that hints at the existence of dark matter. The formation of the Milky Way began about 13 billion years ago, shortly after the Big Bang, through the collapse of giant gas clouds and the merging of many smaller galaxies. In the vast universe, our position in the Milky Way is relatively modest. Our solar system lies on the edge of one of the galaxy's spiral arms, specifically the Orion Arm, about 27,000 light-years from the galactic center. This region is not as densely packed with stars and matter as the center, creating a relatively stable environment conducive to the development of life. From this vantage point, we have a unique view of the Milky Way, able to observe the glittering band of billions of stars when looking into the galactic plane on a moonless night. However, at the same time, we are also partially obscured by dense clouds of dust and gas, especially when trying to look into the galactic center at optical wavelengths. This has spurred the development of infrared and radio telescopes, allowing scientists to peer through this veil and discover what lies beneath.
The Milky Way's architecture can be visualized as a gigantic flat disk with a central bulge and a surrounding halo. The central bulge, also known as the galactic core, is a dense spherical or oval structure containing billions of old stars and dark matter. This is the region with the highest stellar density, where stars are much closer to each other than in the spiral arms. From this core, the spiral arms extend outwards, containing most of the young stars, gas, and dust. There are 4 known major spiral arms: the Sagittarius arm, the Scutum Centaurus arm, the Perseus arm, and the outer arm. Each arm is an active star-forming region where clouds of gas and dust collapse under gravity to create new stars. Beyond the disk and bulge is a gigantic halo comprising dark matter, globular clusters, and some isolated stars. This halo extends much further than the visible disk and is where dark matter predominates, playing a crucial role in preventing the galaxy from disintegrating. The cosmic components within the Milky Way are diverse and abundant. Stars are the most prominent components, ranging from tiny, cool red dwarfs to colossal, hot blue supergiants. They exist at different stages of their life cycle, from newly born stars blazing in nebulae to the remnants of dead stars, such as white dwarfs, neutron stars, and black holes. Besides stars, the Milky Way also contains a large amount of interstellar gas and dust. Interstellar gas, mainly hydrogen and helium, is the raw material for new star formation, while interstellar dust, consisting of carbon and silicate particles, absorbs and scatters starlight, creating dark regions or colorful emission nebulae.
Nebulae are beautiful stellar nurseries where thousands of new stars are slowly forming from dense clouds of gas and dust. Additionally, the galaxy contains star clusters, which are collections of hundreds to millions of stars bound by gravity. There are two main types: open clusters, which contain younger stars, and globular clusters, which contain very old stars, often found in the galactic halo. These star clusters provide insight into the galaxy's formation and evolutionary history. The heart of the Milky Way is a fascinating mystery, dominated by a supermassive black hole known as Sagittarius A star. With a mass about 4.3 million times that of the Sun, Sagittarius A star is located about 27,000 light-years from us and serves as the gravitational center for the entire galaxy. Despite its immense size, Sagittarius A star is relatively quiet compared to other supermassive black holes in active galaxies. However, it still occasionally experiences short bursts of X-rays, indicating increased activity when matter falls into its gravitational influence. Studying Sagittarius A star is extremely difficult due to dense clouds of gas and dust obscuring the view, as well as turbulence caused by other stars and matter in the galactic center. However, with the advent of radio telescopes and radio interferometers, like the Event Horizon Telescope, scientists have been able to capture the first image of a black hole's shadow, providing unprecedented insight into one of the universe's most enigmatic objects.
The formation and evolution of the Milky Way is a complex story spanning billions of years. Current models suggest that our galaxy began to form from the collapse of a giant gas cloud, creating a rotating disk of matter. Over time, smaller galaxies collided and merged with the Milky Way, adding new stars and gas. The most prominent example is the impending collision with the Andromeda Galaxy, the largest galaxy in the local group. In about 4.5 billion years, these two galaxies will begin to merge, forming a new giant elliptical galaxy that scientists call Milkomeda or Milkdromeda. This process will happen slowly, with stars rarely colliding head-on due to the immense distances between them. Instead, gravity will pull the galactic structures together, reshaping them and triggering new bursts of star formation. Studying other galaxies in the process of merging provides valuable insight into how our Milky Way may have evolved and will continue to change in the distant future. One of the biggest secrets of the Milky Way and of the entire universe is the existence of dark matter. Observations of galaxy rotation curves show that visible matter accounts for only a small fraction of the galaxy's total mass. The rest, about 27% of the universe's total mass energy, is believed to be dark matter, a form of matter that does not interact with light and can only be detected through its gravitational effects.
Dark matter plays a crucial role in preventing the Milky Way from disintegrating as it rotates too quickly. Without dark matter, stars at the galaxy's edge would be flung out of the galaxy due to centrifugal force. Scientists are actively searching for dark matter particles through underground experiments and space telescopes, but so far their identity remains a mystery. Additionally, dark energy, a mysterious force driving the accelerated expansion of the universe, also has indirect effects on the Milky Way, Although not directly part of its structure, it dominates the broader universe in which our galaxy exists. Other unexplored mysteries include the detailed star formation history of the Milky Way. Using galactic archaeology methods, scientists are analyzing the age and chemical composition of various stars to reconstruct the galaxy's formation history. This is like assembling a gigantic puzzle without a reference image, relying only on scattered pieces. Furthermore, the presence of exoplanets in the Milky Way is also a vibrant field of research. Thousands of exoplanets have been discovered, and scientists are searching for those that could potentially harbor life. Habitable zones where temperatures allow liquid water to exist are receiving particular attention. The question of whether we are alone in this galaxy remains one of the deepest questions in science and philosophy. Projects like SETI, Search for Extraterrestrial Intelligence, continue to listen for signals from space in hopes of finding evidence of other civilizations.
The potential for life in the Milky Way is immense. With hundreds of billions of stars and potentially trillions of planets, the possibility that some planets have conditions favorable for life to develop is very high. Scientists have identified a galactic habitable zone, an area within the Milky Way with optimal conditions for life, far from the harsh radiation of the galactic center and close enough to the heavy elements necessary for planet and life formation. However, the search for extraterrestrial life remains challenging. Current detection methods primarily focus on searching for biosignatures in the atmospheres of exoplanets, such as oxygen or methane, but this requires even more advanced observational technologies. A better understanding of how life formed and evolved on Earth is also key to identifying similar signs elsewhere. Star formation processes in the Milky Way continue vigorously, especially in the spiral arms. Giant molecular clouds, where gas and dust concentrate, collapse under gravity, forming new star clusters. This process not only creates stars, but is also where heavy elements are synthesized through nuclear fusion and then dispersed into space through supernova explosions. These elements are essential for the formation of rocky planets and life. The Milky Way is a gigantic matter recycling plant, continuously creating stars, planetary systems, and redistributing chemical elements, ensuring that the raw material for the next generation of stars and planets is always available. Each cycle of a star's life and death contributes to the galaxy's richness and complexity.
Additionally, scientists are using radio telescopes to map the detailed gas and dust structure of the Milky Way, looking for signs of hidden structures or dwarf galaxies being devoured by the Milky Way. Data from missions like ESA's Gaia are revolutionizing our understanding of the motion and history of billions of stars, allowing us to build a more accurate 3D picture of the galaxy. This data helps us identify ancient stellar streams, remnants of smaller galaxies that have been absorbed by the Milky Way, thus revealing the galaxy's growth process over billions of years. Every star, every gas cloud, every dust particle tells a story about the universe and our place in it. With each new discovery, we learn not only more about the Milky Way, but also about our own origins and future. Finally, the Milky Way is not an isolated entity. It is part of a much larger structure, the Local Group, a collection of galaxies including the Andromeda Galaxy and the Triangulum Galaxy. This local group is in turn part of the Virgo supercluster. The gravitational interactions between these galaxies shape their fates. The Milky Way is drawing in smaller dwarf galaxies, and in the future, as mentioned, it will collide and merge with the Andromeda Galaxy. This shows that our galaxy is a dynamic system, constantly changing and interacting with its surrounding cosmic environment. Every journey of discovery into the Milky Way is a step forward in understanding the universe, its history, present, and the future of our cosmic home. The Milky Way, with its beauty and unexplored mysteries, is just a small part of the vast cosmic canvas. Other galaxies, especially the most distant ones, hold the key to understanding the early universe. In our next video, we will go beyond the boundaries of the Milky Way to explore quasars and distant galaxies, living evidence of the dawn of the universe.
Prepare for an adventure through time and space, to look back at the first moments of the universe and learn how these enormous energy sources reveal the secrets of how everything began. See you in the next video exploring the early universe.